we are going to begin our notes. We're going to continue our measurement review. We finished this bit on significant figures, we've done this practice, and we're now on unit conversions. So we've already talked about conversions, but first I just want to give you a couple of few examples of what we call base units. Base units are the ones that are fundamental. They are not derived from anything else. So if I say that I'm traveling at miles, 20 miles per hour, well, this unit is derived from miles and hours. But in England, or with the SI system, we don't use miles, we use meters. And we don't use hours, we use seconds. And those are the base units which are not derived from anything else. So meters, what is that a unit of? What's the quantity? Meters is a way to measure distance. Kilograms is a way to measure mass. And seconds is a way to measure time. Here are the prefixes. These will be given on a test. In particular, you'll have the power of 10 and the abbreviation. You'll have the power of 10 and abbreviation when needed. So skip number 2. And we could go ahead and try number 3. But we're going to move on now to graphing analysis. A linear graph or a linear relationship is one that has the form y equals kx, where k is just a constant. What do I mean by a constant? I mean it's something like y equals 3x, or maybe it's y equals 2x. K is just some number that does not change. It always stays a 2 in that example. So what does this look like on a graph? Well, we can make some numbers up. 0, 1, 2, 3. If x is 0, what is y? It's 0. 2 times 0 is 0. If x is 1, what is y? 2 times 1 is 2. Go ahead and fill out when x is 2 and 3. The answers are 4 and 6. Next, I want you to plot these coordinates on the graph provided. So for example, 0, 0 is this data point here. 1, 2 would be this data point. Go ahead and fill out the rest of these data points. When you connect your line, it should look something like this. And that's what all linear relationships look like. Next up is parabolic graphs and parabolic relationships. These have the form, for our purposes, y equals kx squared. Again, k is a constant. For example, maybe k is 1/2. Let's again come up with a table. For each value of x, what do you get for y when you plug in right there? Well, when x is 0, 1/2 times 0 squared is 0. When x is 1, 1/2 times 1 squared, that's just 1/2 times 1, or 1/2. You fill out the rest. We should get 2 and 4.5. Go ahead and plot these, just like before. You should get something that looks kind of like this. Finally, let's do inverse graphs. Those have the relationship y equals k over x. For example, maybe it's y equals 4 over x. One final time we can do our table. If x is equal to 1, or let's say 2, or 4, or 8, what do we get for y? When you plug in 1, y is 4. When you plug in 2, 4 divided by 2 is 2. Go ahead and figure out the other values when x is 4 and 8. And finally, let's make a plot. Pause the video and do this. Your graph should look something like this. It kind of levels off as you approach the x-axis, and it continues going up as you approach the y-axis. But there are asymptotes at the x and y axes. You never actually hit either axis.